Good afternoon, everybody. Welcome to the Quadrant Community Call of June 25, 2024. Short agenda, I think, last time I saw it. Yes, that's good. Okay, update, quick update. Let's see how that goes. Good luck.
Thanks, Thomas. Can you hear me well? Cool. All right, so yeah, this is going to indeed be a quick update. I just would like to share something that I've been working on since last week on trying an implementation of RFC 009, which is the one on defaults and overrides, regarding the second part of it, the part where we introduce the so-called merge strategies, right? So far, we have defaults and overrides at the level of the entire policy, right, that we call atomic, correct? And now we are heading to started the work for the merge strategy, meaning the one where you actually merge two policies together or more policies together, effectively creating a composition of multiple policies in the hierarchy. And that is a work that we've been doing at the same time as we discuss the future of policy attachment upstream with the Gateway API folks, right? So there's an ongoing discussion in GitHub in the Gateway API repo where some ideas have been proposed and they're currently being discussed. And soon enough, we shall have a proper gap with the changes. But basically, they want to incorporate some flavor of this same concept of merging policies together for the inherited policies in the hierarchy. So what I actually wanted to show is that I started kind of a bit of a playground in Golang for trying out the concept of merging policies together by our proposed strategies, right? Actually, there are four strategies. If you combine either defaults or overrides with atomic versus merge, that gives us four different kinds of strategies, right? So either atomic defaults, atomic overrides, or merging atomic at the level of the policy rule, or effectively merging at the level of policy rule. So without further ado, let me try to share my screen and show what I have here. It's still very early stage, but it gives an idea. This is a lot inspired by another Golang playground created by Alex, I think a couple of years ago already, where
Can you zoom?
driven by tests. I can try. Yep. You don't need to read the code too much. I don't want to focus too much on this, right? This is basically the concept, right? It's a test-driven development. So in the tests, you kind of specify the expected behavior, right, when you are merging policies. And unlike the other playground where the focus was mainly on the merge between the policies and how we implement the so-called merge strategies, in this one, I'm trying to combine this with what I envision for the next generation of the direct acyclic graph that we're going to use to model the network topology. We currently have one that models basically the relationship between gateways, HP routes, and the policies attached to those kind of resources. And I'm trying to expand that to basically any kind of network resource. So what you see on the screen is basically a simple test case for merging policies, such as this one, right? Merge atomic defaults into an empty policy. So you have a source policy that you are merging into a target policy in this case, right? And what I would expect in this case this is just a sample kind of policy that I call color policy. It has a very simple spec that allows you basically to set a set of rules similarly to our kinds of policies, right? So the same way you have, like, for example, in the rate limit policy, a set of rate limit rules or in an auth policy, a set of auth rules. In the colors policy, we have a set of color rules, right? That basically only gives an ID for that color and for that rule. I'm sorry, and an actual color for the traffic it targets, right? This is very abstract, but it's just, you get the gist. So if you combine the color policy and its set of rules by following the merge atomic defaults, which in my case here, it's inferred for this particular kind of policy from the policy spec itself that includes a block of defaults or overrides to model the current structure of our kinds of policies. Additionally, a strategy field, also again, it does implement in the RFC, that basically gives you atomic or merge strategies that will reduce to a merge strategy function that will be applied to basically merge this policy with this policy here. And this is what you would expect for merging a policy into another empty one. So this policy defines two rules, and you get these rules, these two rules in the effective policy that you can calculate out of these two. And I have for all different the four merge strategies, and slightly different use cases here. This one, you merge atomic defaults into a policy that defines rules, but does not have any conflicting rules though. Right, such as here, you have rule 1, rule 2, and it's merged into a policy that specifies rule 3. Right, because it's atomic default, the more specific one wins, so you end up with rule 3, right? And so on for all the different kinds of strategies and use cases. Atomic defaults with conflicting rules, atomic overrides into an empty one, into another one without conflicting rules, into another one with conflicting rules, and then the actual merge strategies, merging at the level of policy rule, such as here, merging into an empty one as the base case, merging into a another policy that contains that does not contain any conflicting rule, right? Such as here, if you merge these defaults, rule 1, rule 2 in the source, from the source into rule 3 in the target, you end up with rule 1, 2, and 3. Right? And when you do have conflicts, like rule 1, rule 2, and on the other policy, you have rule 1 again and rule 3, this is a conflict, right? On the ID of the rule. So you end up with because it's an override, you end up with the spec that you get in the source, green in this case here. No, sorry, this is default, not overrides. So you end up with a more specific one, yellow, red, and green. And when it's an override, it's the other way around. Anyway, so we implemented this as in the form of test cases, the merge strategies. I have the 4 merge strategies implemented here as functions, and this is how I imagine this could be provided in the form of a policy library, a policy machinery library, if you will. So when you define a policy kind, such as the color policy that I have here, right, which is analogous again to auth policy or rate limit policy, you would also define the merge strategies along. And from your policy, there must be a way, according to the interface, to get the merge strategy that should be applied from that policy that you use as source. To speed up a little bit here, because I plan to share this, and the actual code will be available for people to check and to comment on. This is not, there's nothing fundamentally new here, right? So this is basically what the RFC describes in terms of the structure of the policy and how we handle the merges between two policies, right? But where I'm actually bringing something new compared to the previous playgrounds and our attempts of implementing this kind of merge strategies between policies is that now I'm also, as part of the same policy machinery, as I'm calling this right now, repo, I'm also defining a generic struct for to model the topology of gateway API resources and network resources in general. Basically, the topology is a struct that allows to model network resources or targetables and their respective policies that are attached to those targetables. And this is the test case for testing this generic topology for a set of gateway API resources that allows to model complex topologies such as this one, starting from the gateway class all the way down to the service port. And this is one of the things new that I'm bringing here. Instead of having only the base kind of gateway API resources as the resources that can be targeted, because we now also can combine in target ref the section name, effectively that gives us more kinds of resources that can be targeted by a policy. If not a resource as a whole, a section of a resource that for the purpose of this implementation here, I'm treating that section of the resource just like any other resource, right? Such as a listener within a gateway or an HP route rule within an HP route, right? Or a service port within the service and so on. So the topology struct is very generic and allows for any kind of resources. So this is me, again, in a test case, using that struct to model different kinds of networks of different kinds of topologies of network resources. So this is, base case, an empty topology. This is a topology that contains only a gateway object, then a topology that contains gateway classes, gateways, HP routes, basically one of each kind, of each base kind, right? A gateway class, a gateway, a HP route, and a service, and a policy attached to one of those. The way I'm building here the test case from the base resources, and I'm scrolling all the way down here, from the base resources, I'm extracting those sub resources, if you will, or those sections within the resources that also turn into targetable objects within the topology. So this allows me to model, and I'm scrolling up again, complex topologies such as this one that you see here on the screen, right? Where you have from, and actually here, two gateway classes, like here, a few gateways, a bunch of routes and services. You see all these boxes here ending up in the network of objects. So you have gateway class, gateways, you have the sub-resource listeners within the gateways. Then you have HP routes that points to either the gateways as parents or the listeners, because if you remember, a gateway, a parent ref within an HP route can point an entire gateway or a specific listener within the gateway, right? Again, by using the section name field. And similarly, if you have a route and within the route you have HP route rules, those rules can list multiple backend references, multiple services as the backends for those rules. And they can point to the entire backend without discriminating a specific port, or they can specify a port within that service. That also gives us another level of in the hierarchy, in the relationship. And hence, the possibility to model service ports as well as a kind of resource that can be targeted by policy. I'm going to run this test case here because this is actually not really testing anything. It's just printing out the representation of that topology in a language that I can export and I can print out. For example, this is the one of each kind topology. So I basically created, it's this one, right? One gateway class, one gateway, one route, one service, and one policy targeting the service. If I print out this here, it gives us a topology like this one, right? So the targetables, so the policy could be targeting, obviously, it depends on the kind of policy, right? My kind of policy targets services in the example. So you have gateway class, gateway, the listener that is defined within that gateway. If I jump here in the code, in this helper function where I create the gateway, it comes with one listener. And from this listener, I got this other targetable resource here. So I could write policies that targets gateway resources with the section name in the target graph, effectively targeting the listener resource, not the gateway entirely, right? In this case, my test policy is targeting the service. I only have one policy, so there's nothing too much of merge to do here. But you can imagine if I had another test policy and imagining that my test policy could target not only services, but other levels in the hierarchy, what I want to do next here is to navigate this topology from the lowest level here all the way up to all the possible roots of the in the tree and get all the possible paths between the roots and the lowest level that my policy affects. And then for each path, compute the effective policy. This becomes more clear if instead of printing this simplified topology, I go with that complex one. This one, I did not create any policy, right? So I'm going to print only the target poles here on the screen. But this is a very complex topology that I created with two gateway classes, multiple gateways. Some of these gateways declare only one listener, others define multiple listeners. Similarly, multiple HP root with one or more rules inside of them, pointing to services with one or more ports specified in the services, and the relationship between those resources all inferred from the spec. So this is the topology we get. And you can imagine a kind of policy that allows targeting one or more or multiple kind of resources in this hierarchy. And the different path you can imagine depending on the case, right? For example, let's say we have a policy that allows targeting HTTP routes and gateways. But in both cases, we also include the section name in the target graph. If that is true, that means that you actually can target 4 different kinds of resources. If you combine the base kind of the resource with the section name, that gives you gateway or listener or HTTP root or HTTP root rule, right? So let's say you have a policy attached to this HTTP root rule here called rule 1 inside of rule 3, right? And then another one targeting the gateway 2. So we would need to compute the effective policy for all the traffic passing through HTTP root rule 1 inside of rule 3 when it comes, in this case, always via gateway 2 here, right? Which is defined based on gateway class 1. On the other hand, if we choose another node here in the tree, such as this one here, right? HTTP root rule 2, which belongs to this HTTP root. This HTTP root is actually attached to 2 listeners because it defines as a parent ref the entire gateway. And if this gateway defines 2 listeners, that effectively means that there are 2 listeners that are the parent this HTTP root. So you can imagine traffic flowing through this HTTP root and from this HTTP root to this HTTP root rule coming from this gateway, but flowing through this listener or through this listener. Again, if you have a policy that targets the gateway with the section name, actually the policy targets the listener. So you may end up with one effective policy when the policy is targeting this listener and another policy targeting this rule, and yet another effective policy if you have a policy targeting this other listener with the same policy targeting this rule here. So this is the next step here of computing all the effective policies for all the possible paths, depending on the multiple levels you can target something in the hierarchy. And this is what I would like to share.
That's cool, Guy. Is this making it all into, I see you're talking about the, sorry, DD, the policy library. So is the plan for all that to be implemented there, and then we'll bring the policy library into the Kuadrant operator? Or is
it's a good question. I created a policy machinery repo. It's only local. I didn't push it to any remote. This could be another repo, or most likely this could all become the base for the already existing Gate API machinery repo. With the only difference that the Gate API machinery also includes a bunch of helper functions and tooling in general for doing the reconciliation part of things as well. So actually divide this into three parts. So you have the policy merge strategies, one piece. Another one is the topology. And finally, you have the reconciliation. So we hope that the so-called DAG 2.0 becomes kind of the base for all those things, right? For working out the merge between policies, given the provided merge strategies, the implemented merge strategies, but also the base topology, and ultimately to allow controlling the reconciliation of the resources. So when we combine the part of the reconciliation as well, I think that will become eventually the new Gate API machinery thing.
Okay.
Because this is all based on policies, right? I decided to call it policy machinery for the time being. But we can call it Gate API machinery and just use as the next version of that repo we have.
Okay. And seeing as I jumped in front of DD already, I just have one other comment, which is modeling these resources in the way you have and these interactions. Does it essentially highlight that there may be either that there may be some suggestion or some proposal to Gateway API about, like, do you actually want to allow this scenario? Right? Like, is there value in this scenario, or is there just complexity in this scenario? Right? Does that make sense?
I guess you're talking about the most complex scenario I showed here.
Yeah, like where you had like two listeners with a HTTP route attached to the gateway, so it's attached to both listeners, and two separate policies attached to two independent listeners. I'm not saying there's no value in that. I'm just sort of saying maybe as you're modeling this, it may highlight places where there's a lot of complexity and maybe not enough value to warrant the complexity.
Well, the good thing is that the implementation does not hard code that topology that I showed, right? Rather, what you have is a very generic structure receives a set of targetables and a set of functions that allows to linking the targetables one to another, right? So that basically allows you to model any kind of topology you want. If you have a topology that is that's simpler than that, say for example that you only you need that only for policies, for kinds of policies that do not include in the target graph the section name. So you never need the listener in between gateway and HTTP routes, right? If you're only targeting the entire of the gateway, or again the entire of the HTTP route, but not at the level of each HTTP route rule, then you can use the same library to model just gateways and HTTP routes.
Yeah.
You don't even need the gateway class, right?
So I kind of gathered that part, right? But I guess my comment was more of, as you model this, you may see complexity in the gateway API structure that's allowed, that maybe is creating a lot of complexity, but is not resulting in a huge amount of value.
Right. So you're saying that maybe that can motivate the discussion of how we can reduce that complexity upstream,
Yes.
right?
Yes.
Interactions, yeah. Basically, that comes from the things that are already there, right? Basically, just target graph with section name and combined with the different kind of resources from Gateway API. Only that gives us that complexity.
Yeah, and I guess, like, just to reiterate a little bit, is by modeling it, you see that complexity. So it may be an opportunity to talk to the Gateway API and say, I want to show you something, which is this, right? This could be a situation a user ends up in. Do we see a reason to restrict it so that a user doesn't end up walking down this path? Or do we see enough value in allowing this level of complexity that we want to keep it the way it is,
Right. To be fair, yeah, I think that's so sad. And to be honest, I believe that many people in that group already has already seen, have already seen that complexity. And I can tell from comments such as of people suggesting that inherited policies do not allow for section name in the target ref. In fact, that is the current state of things, right? The current state of things says that only direct policies can use the section name, precisely not to get into this problem of how was it called, the combinatorial complexity of all those things that one can do in policies and why you're designing policies and combine with the existing APIs.
Because I also saw like something that may make it. I'm going to stop talking now in a second. Sorry, Tom. I saw something today that may increase the complexity further, which is the combining of gateways, right? Or the merging of gateways. So you have gateways that are merged, then you have like policies that are merged, and like, oh my God, it's starting to like go crazy. So, yeah, I saw that today. So anyway, I'm going to stop now. It's great to see that. Thanks, Keith. Thanks for sharing.
Yep.
Yeah,
you might, sorry, one second, Didi. You might want to switch to not using your headphone because I don't know what's happening, but it's getting worse and worse. The robot voice that goes, it's weird noise. Key.
Better now.
Yes.
That's why we pay 500 euros for a headset.
Exactly. I'm just jealous. I'm just happy that I can say something negative about it. Sorry, Didi.
Yeah, Didi?
Good, thanks. So first of all, thank you, Gil. This is looking really good. I kind of like love it, your approach to it. I just wanted to continue on the complexity that we can imagine in these topologies. It could be when you calculate all of those, probably the second example of the topology, the more complex one, it could get like even like nastier than that. And I think like when you calculate the effective policy and you get like with many circular dependencies, it could end up being like a very heavy calculation probably to get the effective policy for the service. But because in the end, very end, what we're trying to apply, they're like policies, rules for services, no? And I just wanted to ask you, if you also wrote any tests for this, like map reducing these heavy topologies and calculating those effective policies. Probably those are going to be calculated on time, or you're already calculating on builds, or how do you imagine? Many questions actually there on my rambling.
Right. So calculating the effective policy is going to be my next step here. We already have, the base for it. So we have the topology, we know how to navigate the topology, and we have the merge strategies implemented. So basically, I'm talking about combining the two things together, right?
Mm-hmm.
So we will navigate that tree that you saw from the bottom up, right? And finding all the paths that are relevant for applying a given kind of policy. And we will basically apply those merge strategies for each pair of policies we find from the lowest one to the highest one in the hierarchy. Basically, that's how we're going to get the full set of effective policies, plural, right? Multiple effective policies for each case. There was one thing that you mentioned, though, that I think it's interesting. You mentioned some circular dependencies. I'm not sure exactly what you meant by that, but that made me think that one of the reasons why we modeled this as a direct acyclic graph is precisely to avoid, the loops and any circular thing while you're navigating the structure. So one guarantee that we have is that the topology will always be acyclic. So you never run into loops that requires any I don't know, complexity of the kind of thing that you need to track the nodes that already visit, this kind of stuff, right? So you can just pass once and get the path between two nodes in the hierarchy. You also mentioned, we want to compute that for the backend, right? And or the services where we want to protect. Service is one level in the hierarchy, right? If that happens to be the level where we want, for which we want to compute the effective policy, it can be, right? Currently, It is not in our case, right? I showed a very complex topology that starts from the gateway class and goes all the way to the service port. But in our case, in the quadrant kinds of policies, we don't need that. We can start in the gateway and we can go all the way to HP route rule and nothing lower or over that, right? So only between those levels in the hierarchy. So it becomes slightly simpler because in the end, that's how we configure the gateways for, right? We configure it based on the rules we get in the specifications of the HTTP root rules. Basically, the rules that describe path, method, and all the HTTP attributes that we want to match, and so decide which policy or which effective policy in this case to enforce. So it can be simpler depending on the kind of policy. This level of complexity between gateway and HP route rule, including listener, HP root, right, and in the middle. So basically, we're talking about 4 levels. Those 4 levels are the levels I believe we need for the current kinds of policies we have. Because of DNS policy and TLS policy allow you to target a section of a gateway in the same fashion that the rate limit policy and the auth policy allow to target a section of an HP root. We actually need those 4 levels, all 4 levels.
Right. So the effective policy will depend on the characteristic of the request itself, depending on which path it took down to the backend, and those are going to be calculated depending on the listeners that they were attached to the gateway. Okay.
Yeah.
Am I correct?
Yes.
Okay.
And the characteristics of the request as given by the spec of the HP root rules, right?
Right.
So as part of the HP root rules are the ones that define the possible characteristics of the request that we want to match against.
I see. Yeah. So what I meant by I actually cyclic wasn't because yes, it's like we kind of like avoid all those relationships, but I was thinking more sometimes when you have like overrides on listeners and defaults on gateways, and if we could get nasty into that calculation itself. But probably I'm just thinking without actually without having like sorry, just lost my mind right now. I don't have an example out of it, but
no worries, Didi. Let's leave that for next week when I hope to be able to demo the second part of calculating the effective policy.
Good. Thanks, Guy. It looks fantastic.
Thank you, Thomas.
Yeah, I want to go back to those examples with the colors. Why did you choose colors? Because in my head it makes it more complex, because then I see blue and yellow and green suddenly has a meaning. Then is that on purpose?
That originally we had a simpler kind of policy that was not a set of that wasn't defined as a set of rules, but rather just one single spec, right? So it was one single color. So we had a color policy that either was to apply like blue or green to the traffic flow into this target graph, right? But because I wanted to model for policies that look more, alike to the quadrant kind of policies, so I expanded that to a set of rules. So don't think too much on it. I mean, in the end, what you want is whatever is being targeted by this policy, we want these rules enforced. This is the idea, right? So we have rule 1, rule 2. Maybe you can imagine inside of those rules more specific definitions, such as when conditions, right? Things like that, right? And then the idea is it would either tint the traffic blue or green or yellow or any color specified for that rule.
Okay.
I believe that's slightly easier to think about compared to rate limiting or all use cases.
Okay. Yeah, maybe not for me, maybe, but I'm not trolling, Greg. No. Okay, but I'll leave it there. Yeah, another thing I was wondering, like if we also start supporting cell, that wouldn't affect all of this, no? Because that's inside of it, or would it?
Well, we are considering common expression language cell for a couple of different applications. One of them is to decide whether a source policy will be applied on the target one or not, right? And basically that will allow us to model for the constraints use case. So you would only apply a source into the target if the set of conditions expressed as a cell expression matches. Otherwise, you would just skip that one in the hierarchy, right? That's one application to be considered in cell for. I didn't implement that part, but it should be very easy to do. It's just a minor modification in the four merge strategy functions that we have there.
But would the effective policy still potentially contain variables or not?
What do you mean by variables?
Well, the cell, the structure, like if something, if this is equals this, then do this. That kind of thing would still be in the effective policy.
In the effective policy, we would probably only get the ones that are meant to be executed in the data plane.
Right.
Like conditions that you need.
Right. Like header or what? Yeah. Okay.
Yeah.
Interesting. Okay. Yeah. Well, I think Greg's point was also a good point. Like sometimes with these things, you get the feeling like are we doing it because we can? And just create complexity, or are there actual use cases of this complexity that ask for this? Like, is it value, or is it just we're really smart?
Well, yeah, I don't think it's only because we can. I mean, it's the APIs are there already, and they are V1, right? So people can create resources that look like that in the end, right? So that kind of topology is perfectly, acceptable. And we are trying to come up with a tool that allows designing any kind of policy that could target any of those kind of resources, right? Only with the definitions we already know of target graph, with or without the section name. That's it, right? And that will happen whether we want it or not, whether we try to model that or not, right? It will just happen. Our kind of policies already leverage all those things.
Yeah, okay, but you could still envision that you could revisit some of those earlier decisions and say, well, yes, you can do that, but only one per. I don't know. You can still limit. You can add new rules to the spec that limit this kind of that it cannot grow.
I guess what you're saying is that we could start dropping use cases, because that spec that we wrote came from a set of use cases, right? That we proposed at the beginning of it. So we need to do those things to deliver for those use cases. If tomorrow we say, I do not want to allow setting a policy only for a portion of an HP route, for example, it has to be for the entire HP route, then so be it. Probably you would have, to deal with the side effect of that. That would be probably people start splitting their HP routes into multiple objects, so they could have policies that target only one of those objects. Then again, another one, we would need to start merging policies together all the same. So
No, yeah, sure.
I think what makes this uneasy is the realization that that complexity was there from the beginning. We've just been ignoring that.
Yeah, no, I get that, but still you could say that's engineered complexity and not on complexity really based on anybody needing that kind of complexity, because maybe there's nobody with that topology out there that needs that and it's just like all in minds of engineers, and we've created this complexity. Like, you know what I mean? But I mean, I'm talking.
I need to link back to the use cases, right? The use cases, they are described as a paragraph, but that's what they need to be delivered. When you say, I want to rate limit only the request that matches the header X, that's what we're talking about, right?
Yeah. So Thomas, what I was kind of trying to highlight was not what. Thanks. What I was trying to highlight was not the complexity that we were creating, but rather the complexity that has been allowed by the Gateway API.
Yeah, no, that's what I meant to.
Yeah. So it's not questioning like how we create a effective policy based on that hierarchy, but rather maybe we should hold on to this type of complexity, so that, because inevitably there will be a V2 discussion about Gateway API, and this kind of thing might feed into that and say, oh yeah, remember how we managed to create this ball of mud? Let's see if maybe we need to rethink some of that to stop that ball of mud. And do you know what I mean? Like, just sort of, we're forced into this solution because Gateway API allows a huge amount of flexibility. But the question I suppose I was asking was, although it's like incredibly flexible, has Gateway API kind of shot itself in the foot a little bit by being so flexible that it's like, you know, it's a bit like C, it's like a handgun, right? Like, yeah, you can do this, but you probably don't want to, right?
Right. And one thing would for Kuadrant to limit then the possible things that we support, but that's not what you were talking about. You were talking about going back with that information to the root level Gateway API.
Yeah, well, maybe a bit of both, right? Like, if we think there's just something that is not something that we should support, then that's a different debate. But more like, yeah, going back to Gateway API with this type of layout and asking the question of, is this type of topology something that we want users to be able to create? Is this valuable? Is it valuable, right? Because if it's valuable, it's valuable. If it's not valuable, and maybe we don't have the answers right now, right? Because we need users to go out and use it and create the topologies and come back with the messes they've created and say, so how do I sort this out? You know, so maybe, yeah, but it's definitely a V2 type discussion, because it may mean some breaking changes to the API if everyone agreed that, like, okay, yeah, we probably shouldn't allow that, or whatever the case may be.
Yep, great. Though it's something to be said that that's actually the wrong order. Ideally, you want an API that doesn't allow you much, and then people start using it and asking you, "I really need this," and then you add it instead of having to remove things later. But
yeah, I would suggest that like Gateway API has evolved from the learnings of Ingress, right? Ingress is like a super limited API, and maybe maybe it's possible that we've gone too far the other way, where it's like really unlimited now. So, you know, maybe V2 would be a balance. Yeah. Like, if you think of like even OpenShift routes, right? Like, there was not a lot you could do in that. And what happened is everyone started creating annotations on those things to do extra things. So it's, yeah, as everything's a balance.
anything else? Nobody added any more items to the agenda, no? So, yeah.
I did have a question for Guy about some of the Gateway API stuff, if we have like minutes. So I'm just catching up on stuff. I saw that Nick has weighed in on the DNS policy discussion. I wondered if there was anything brought up at the meetings around it, or is that something he's done independently?
Well, I haven't been to all the meetings, but only the ones that are in our time zone here in Europe. But I don't remember the DNS policy being mentioned, other than before closing the list of new features being promoted in 1.2, whether to experimental or to GA, right, to standard. I remember Nick mentioned that he wanted the DNS policy to be one kind of policy that would be part of Gateway API itself, rather than a policy that it's provided only by third-party providers, right? But it would be part of similarly to the backend TLS policy or the backend LB policy. So he believed the DNS one is a good candidate for becoming core in Gateway API. But he wasn't talking about our DNS policy, right? I think it's the one that's being discussed there that you started the gap, if I'm not wrong.
Yeah. No, he weighed in on it, and he seemed quite positive and was sort of trying to help have that discussion with, I can't remember who it was, but somebody was sort of against it originally. I just wondered if there was any more context to that before I started getting involved in it. So
I guess that's all targeted in 1.3 now. Yeah, I also remember of, I think there was an SRE guy that commented on the issue, right? Saying that,
yeah.
maybe anyway, I remember that.
Anyway, he had some suggested updates, so it's great to see that actually having a little bit more engagement. I need to make some time and actually get back to it now. Okay, thanks, Guy.
Sure.
Yeah, thanks. Okay, if there's no other questions, remarks, or anything, then thank you, everybody, and see you next time.
Thank
Take
you.
care.
Cheers.
Bye.
So